Okay, so let's get started. First of all, as promised, let's go through and talk about the final exam for a few minutes. I'll flip through the slides and point out the things that stand out as being extra important and etc. Um, let's talk about the format first. So final exam, there will be 10 questions, all short answer, essay, or programming. So that means no, true, false, multiple choice, etc. None of my exams ever have those things on it. So pretty much what I'm describing here is the types of questions you will have in any Lytton class for my exams, including the format of 10 questions. So you can probably expect about half the questions to be programming in some sense. So that includes writing or reading code and telling me what it does. There will be at least one conversion question. So that is convert from some numeric base to another numeric base, or from a size to another size, like megabits to gigabytes or something like that. All right, so those are things that all computer science folks should be very, 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 very comfortable with day one. Well, let's call it semester 2 of their computer science career. We should be the ones who walk into Best Buy when we're allowed to walk back into Best Buy. I realize it's only curbside service at Best Buy, which was actually fairly convenient the other day. But once we're allowed to walk back into stores, you should be the one who can go up to something and be able to do that translation when they try to make the number look impressive and say this is a 75 trillion bit hard drive or something. You should be able to turn that into gigabytes or terabytes and that kind of stuff. So that chart is in our notes here. So remember, it's just one bit. One byte is 8 bits, so you have to multiply it by 8 to go between the two columns, and then it's times 1024 up and down the columns. Because there's 1024 kilobits, or 1024 bits in 1 kilobit. There's 1024 bytes in 1 kilobyte. There's 1024 kilobytes in 1 megabyte, so on and so forth. All right, so there will be at least one conversion question, maybe even two, one of each kind. So these should be basically free points. Make sure you show your work in case you make a little math mistake. I can give you most of the points because you showed me you knew what you were doing. You just had a hiccup. If you just give me an answer and nothing else, and you give me the wrong answer, I have nothing to give you partial credit for. So take that into consideration when you consider your confidence in your answer. If you just give me the right answer, I'll give you the points. But otherwise, show your work, or show me enough of your work that you understand that I'm convinced that you know what the deal is. The other questions will be more theory-based questions, kind of like purpose of a class, or maybe give me a breakdown of how you might solve a problem given a scenario, in terms of what objects you might create, things like that. Let's see. Book exam is closed. Book closed. Notes closed. Google closed. Neighbor. Etc. I want to see what your competence is. I grade my exams from a competency perspective. I'm not going to take off points, if you're missing one little colon somewhere that you would have easily debugged when you tried to run the program. I'm looking for, it's usually pretty clear to tell whether this person mostly knows what they're doing or really hasn't caught on completely yet or is completely clueless. All right. If you, I haven't caught on completely yet, or you mostly have it, if you're in one of those two categories, you're okay. You're where you're about, you should be coming out of 200, because you're still supposed to not be very good at programming, but you should feel like you're a lot better than you were week 2. And you know, your skills are going to keep growing as you go through the rest of the classes. If you're completely clueless at this point, well, then you need to ask yourself the question of why you're completely clueless. Is it because you haven't been doing enough of the work on your own and you've been relying on other people to help you with your homework? Is it that you're not even doing the homework? Is it that you're just not cut out for this? Is it lack of effort? Whatever it is, you know, try to determine why it is that you're clueless at this point. And if it's because of effort, that can be fixed. If it's just not your cup of tea, that's okay too. You have many God-given gifts, I'm sure. And you should go and find what those are so you can, you know, get into something that you will find fun because you're good at it. Okay. And I'm happy to have those discussions with you if you have concerns about whether this is your cup of tea. For most of you, I've reached out if I had some questions about whether this is for you. And so if I haven't done that, then I don't have concerns at this point. So you can bring your concerns to me if you would like. Okay, so that's the format of the final exam. I will, let's see, exam will be up by midnight tonight. So what's today, Friday? Did I get that right? It'll be up by midnight tonight, and it will be due by midnight on Friday of finals week. So next Friday night by midnight. You can sit down and do it at any point in time between tonight and next week, but you have to do the entire exam in a single sitting. Exam is designed to take about an hour. So even though usually final exams are 2-hour periods, I rate all my tests to take roughly an hour. But I will set time limit for the exam at 4 hours. So there should not be a time pressure. Okay, so bottom line is this exam, you should not be in a situation in this exam where you're coming up on the end of 4 hours and have not had an opportunity to answer every single question multiple times, probably. So for those of you who sometimes get extra time for exams and things like that, you don't even need to request that. You'll have all the time that you'll need. I just have to put some time limit on the thing so that Blackboard will automatically submit it at the end in case you just walk away. Okay, so should be no time pressure. Plan on it being as if you had a real 1-hour exam when you're setting aside your time for it. So if you know that you're an average exam time taker, you can kind of figure that you're going to need an hour of your life. Maybe you give yourself an hour and a half for some wiggle room, but nobody should be taking 4 hours on this thing, but you have it if you want it. Let's see. You can use a calculator. You can use a text editor for code formatting, but don't run the code to test it. And actually, that's there's two sides to that. One side is that I don't want you wasting your time trying to test code that I'm not grading for perfection. I also don't want you to take this 4-hour time period to go through every permutation of 6 lines of code until you get something that actually ends up working, because at that point you haven't shown me that you have competence. You've shown me that you can, try to stick a square peg into a round hole 4,000 different ways. So write it from your own competence. Get the syntax as close as you possibly can. If you want to use an editor so it gives you some formatting so that when you paste the answer into the exam, it looks a little cleaner, that's fine. I don't have an issue with that. So any sort of tool that's along those lines, I'm fine with. Just nothing that'll test the Python, nothing that lets you look up things. You should have the competence at this point. I suppose I would say this: if you know you need to use a certain function and you just don't quite remember what the parameters are of that function, I'm okay with you Googling that. Because at that point, you're still showing me your competence. You just knew, like, oh, I needed to use split. Does that take 1 or 2 parameters? Something like that. So use your best judgment. Just don't cheat. All right. I'm not going to sit here and go and look out for people who've cheated. You're only hurting yourself. So, it's not really a concern of mine, but, if my job is to prepare you to, be professional programmers one day and go out in industry and do something, it's important that I get legitimate feedback from you, and it's important that you get legitimate feedback from me. And all I can tell you is that I'm going to be gentle early on in your computer science career until it really, really starts mattering. You've had the 2 or 3 years of practice under your belt where you really should be much more competent. All right. So show me what you got, and I'll try to be gentle in the grading, with the understanding that I want you to continue to develop your skills, not be dissuaded by a lot of hard work that didn't turn into a reasonable grade. Okay. All right. So questions about the exam format before I go through the slides and kind of point out highlights of things that I think are extra important. Okay, everybody's happy. All right, so let me, I'm gonna go, let's start with where the midterm was. And I'm going to focus on things post midterm. Okay, so this was the midterm solution. Okay, so not that, programming is being a skill set, everything builds and everything else. You're still going to need to be able to define variables and write loops and all that stuff. And those are things that we did in the first half of the semester. But the emphasis on this exam will be on the constructs that we looked at since midterm. And the focus for that is the idea of objects. So effectively dictionaries on steroids, right? Understand objects. So anything dealing with objects, fields, constructors, functions, those should be very much bread and butter for you at this point. Know how to use dictionaries, functions, understand how those guys relate to each other. Classes, fields, constructors. Definitely have a strong understanding of the self keyword. How self is how an object refers to itself from within itself. That being that when an object wants to talk about one of his fields or one of his methods, he says self dot. When he's just talking about a generic method or a generic variable that's local, he doesn't say self dot. It's just a variable resolves to its most local definition. So be able to wield the self keyword when it's appropriate to use, and that's how an object refers to itself from within itself. Again, this idea here, I've mentioned it a couple times already, so hopefully that tells you it's true. Reading code is very, very important, and one of the things that hopefully you've noticed already is that you're significantly more skilled at seeing a correct answer and understanding it than you are writing it on your own. that's going to be the case for a long time, and that's okay. That's where you should be. You should sit and struggle with the assignments when you have to write it on your own, and then when you see the answer after going through all your experiences you had when you were working on it on your own, you should kind of say, oh, this is where I went wrong, or oh, that makes sense. That's where the learning is actually taking place. But this idea that all variables and functions, for that matter, boil down to their most local definition. Now, I say functions, for that matter, that relates to inheritance, which we've talked about more recently. So when I make when I talk about a variable, or when I try to call a function, it's going to look in my most local scope for that variable or that function. If it can't find it there, then it'll go up to the next scope. It'll go up to the next scope. And as soon as it runs out of places to check, then it screams and says, hey, I don't know what you're talking about. All right, but that's how variable resolution and function resolution work. Yeah, methods are the object-oriented name for functions. You know, on the exam, I won't ask you questions about, like, you know, how do you do fraction math or something like that. I might give you a problem to solve that, requires you to know some math stuff, but I would almost always give you the formula for it. You know, I wouldn't expect you to like have, I mean, you probably should have a lot of these things memorized, but this class isn't about math formulas. You know, I'm not going to assume that you have the, you know, area of a circle, memorized or something like that. I'll give you any formulas that you might need that I'm asking you to replicate. Time complexity problems are interesting. That probably does not make it on the exam as a question. It's one of those things you want to keep in the back of your head, know that it's something that exists, where sometimes you have solutions that seem like they're relatively simple, but it's not a practical, testable thing for this course, let's say. Similarly, I'm not going to ask you about specific algorithms, like, you know, how does insertion sort work? I want to see your skill in wielding programming. That isn't to say that I won't ask you to search through a list of stuff, or, you know, I guess potentially sort. I probably wouldn't ask you to sort something just from a time perspective. But, you know, you should be able to wield the programming language and go through lists and go through dictionaries and all that stuff. But in terms of having to memorize the insertion sort algorithm, don't waste your time on that. Whenever you need to write an algorithm for something, you'll be able to go and reference the Wikipedia for it or something like that and see, oh, this is how this algorithm works. I'm going to translate that from English into code. All right, so that won't be something I'm testing you on. Certainly understand this concept of pass by value versus pass by address. Remember that our primitive types, like ints and numbers, booleans, these are all and strings, these are all passed by value, versus lists, dictionaries, objects, these are passed by address. So when we pass something in by address and we make a change to it, that change is permanent. All right, and then we get to our more recent, kind of culminating project, which uses objects, which uses all the things we've used this entire semester. So again, I'm not going to ask you something very specific about, you know, in our player object, list the 4 fields that this guy had or something. I'm not asking questions like this. I'll give you the information that I want you to implement, and I want you to show me the code for it. Certainly understand this concept of data representation languages. That has been a big thing here in the last part of the class, and it's something that will definitely make an appearance on the exam in at least one question. I'm not going to ask any specifics about like CSV or HTML or XML. Those are things we didn't, we mentioned as this is part of the evolution of data representation languages. But the bread and butter here is this idea of file IO in general, and then working with JSON, with the concept of if we want stuff to persist between runs of our program, we need to have that stuff stored external to our program and read it in and write it out at the end of the program And JSON is a good way of accomplishing this because it's a current modern standard that pretty much all computing systems use that are created in any sort of recent years to communicate. And even if they use something older like an XML, understanding the problem that JSON is solving will allow you to say, oh, okay, well, this is just the XML version of this, and I'll have to find Python's XML parser, which does exist and lets you split an XML string up into its parts. But for us, JSON's the bread and butter. We should look at that and say, this is the way file I/O should work. Because if I store stuff in my file in JSON format, then I get all sorts of advantages of conveniently being able to move it into dictionaries and that kind of stuff. But this idea of using JSON, doing stuff with it, the load S and the dump S function for going between strings and JSON objects are things that you should be familiar with. Like here, this would be a reasonable example of like a programming question I might ask you to do. I might ask you, write a function that takes in a string and returns a list containing the contents of the string separated by spaces, something like that. So you could either go and use the split command, or you could just write your own function that goes and builds up the strings. But those are the kind of like little drill programs that I might ask you to write on an exam. Manipulate a string in some way, manipulate a list, go through a dictionary, that kind of stuff. Showing me that you have some programming competence. I probably am not going to ask you anything about design patterns. They're super important in programming, but they become a very core topic in what we'll deal with next semester when we look at some Android programming and stuff like that. We'll also probably do some Unity programming next semester, doing some game programming stuff. With that idea of, I like to keep moving you between technologies so you start really believing this idea that programming is the skill set, the language really doesn't matter. Every tool has its little nuances, but once you get past that, you realize you're still writing if statements, you're still declaring variables, you're still writing loops, you still have classes, all these things exist in all these different languages. But these idea of design patterns are very much an important part of the 250 class. So we'll focus on it there. So I just introduced it here, I won't test you over it. You should be able to read and write from a file. Chances are I'll focus on JSON, but JSON exists regardless of whether files exist. You can work with JSON just internally in your program. So treat file I/O as a separate skill, but maybe a related skill to working with JSON. Kind of our 1-2 punch is, hey, let's store JSON in a file and read it in, as opposed to let's store something in a file and read it in. But if you had a text document that you had to read in, and I asked you to count the number of times the word and occurs, you should be able to read it into a string and then go through that string counting the number of times it finds and. There'll probably be a question on inheritance, one question. I know we just dealt with it more recently, but this idea of being able to kind of build objects in terms of other objects, so we reduce the amount of code we're duplicating. I probably won't ask a real deep question about inheritance, but you should certainly understand the concept of it and why we might need it or benefit from it. Similarly, the super keyword, the self keyword 100% makes an appearance on the exam. The super keyword probably shows up, probably in the inheritance question somewhere in there. You should understand that super is how an object refers to its parent, and self is how an object refers to itself. I doubt I'll have you write code that leverages super, because at that point we're starting to get into some of this stuff that's much newer, you've had less practice with, and I'm really going to be testing you on that stuff significantly more next semester. So know what super is, but I doubt you'll have to use it in code. Okay, so now let's go before the midterm, and I'll just point out any things that I think are extra important that might make another appearance. Certainly this concept of how humans solve problems, but I doubt very much I'll ask you to just like mimic this on a question. That should be something that's ingrained in your soul now, that humans solve problems using their memory, asking questions, and repetition, and all programming languages have facilities for those three things. And that's that mindset for why, like, next semester, we're going to use 2 different programming languages inside of 2 different technologies, Unity as well as Android. So you're going to be writing Android applications and you're going to be writing Unity applications. And if you're an iPhone user, all the stuff you're learning about Android writing will translate very easily over to writing stuff for iOS. In fact, I prefer iOS development. Just the only reason I use Android in class is not all of you have Macs. And Xcode, the tool you use for writing iPhone stuff, is a Mac tool. And you can't run the Macintosh operating system in a virtual machine, at least not legally. There's some hacks out there, but we'd probably be doing that, but we're not. So that's the rationale for picking Android. It's not that I use an Android phone. My wife uses an iPhone because I write software for both of them. I used an iPhone for years, but I don't really have a preference. I like coding for iOS better. I think their tool is better, but I like the Java language that Android uses better than I like Swift. So pick your poison, but you'll be getting a skill set, again, that applies to all sorts of different things next semester, because you're going to be learning the skills to write video games using C# and Unity, and you'll be getting the skills to write Android applications using Java and Android Studio. And you're going to see real quick that the programming aspect of those has very little differences, very few differences. All this history stuff, I'm not going to test you on this. I think I kind of said that in the last exam. It's important. You kind of have to have a context of where we are and kind of the evolution of our languages. But these are not things, these are almost cornerstones of things that you're going to run into in some of your other computer science classes. This idea of how the internet works. This is stuff you will run into in other classes, but it's not a skill that I'm directly testing in this class. But it was a foundational piece that was important to kind of have there so you can understand the context of things I was teaching after this. So I won't ask a question, for instance, about this slide specifically. Same thing, I'm not going to ask you about these technologies. Again, it was to build that foundation up. In general, I'm not a big fan of memorization. So if you find yourself in a situation where you're like, I have to memorize this in order to do well in the exam, chances are I'm not going to be asking that question. The only things I'm, like that whole memory, asking questions, repetition thing, I kind of want you to have that memorized, but not even having to try to memorize it. It should have just happened from repetition at this point. But very rarely will I ask you anything that's just going to require you to like regurgitate something out. Here's that memory size chart that I referred to earlier. You should know how to do this. And this is not a memorization thing. This is, well, I guess you have to remember 2 things. To go from this side, the left to the right, you multiply by 8. To go from the right to the left, you divide by 8. And then to go down the list, you multiply by 1024. To go up the list, you divide by 1024. Those are your moves. So if you can remember 8 and you can remember 1024, both of which are powers of 2, you have everything you need for this to reconstruct this chart. And here's like a conversion for that. Like, if you have 200 megabit per second internet at home, how many megabytes per second is that actually, and that kind of stuff. So this kind of allows us to see some of the misleading advertisements on TV, where they're all the commercials for internet. It's like, oh, you have 200 meg internet. They like saying that because it's misleading if you don't know if it's megabytes or megabits, but it still sounds cool. They usually have a little flame thing on the screen or something, but as computer scientists, we know the truth. 25 megabytes per second is still all right. You'll be able to get by with that for right now. Certainly understand the concept of pointers. We don't use them heavily in here directly, other than the idea that when something is passed by address, it is passed as a pointer. So I'm not going to ask you questions directly related to the word pointer, but you should certainly understand that concept that if a function gets a memory address that points to something like a list, and we make a change to that list, we're changing it actually in memory, and that change will have side effect in other parts of our program. Pointers become a very, very, very integral part of the 300 class, where we do C++ programming, and everything you're doing is dealing with memory and things like that. It's a lot of fun, but it's that's getting pretty technical, and that's not where we're at right now. We just want to appreciate that, hey, you give me a memory address and I make a change, that change will be noticed everywhere. If you give me a copy of a value and I make a change to it, that's only a local change and nobody else needs to know about it. Similarly, these guys, I'm not going to ask you about these. These would have been midterm exam type questions, but also, again, the foundation for programming languages. How CPUs work. Again, you should understand this when you go and take the 325 class next spring. This is going to be a major, major, major portion of that class. In here, it's the context of we're using a programming language to communicate with this guy. I'm not testing you on this guy in this class. I'm testing you on the programming side of things. Okay, but he's a part of the story, just not the part of the story that we're really interested in this class. You should obviously be able to, know that, oh, if I'm going to concatenate, I need to use strings, or know to use an F string. So if I need a number, I need to turn it into a string. I need the string function. If I have something I want to turn into an int, I can use the int function. Be able to form Boolean expressions, because we need those for our if statements, our loops, blah, blah, blah. Be able to write if statements, conditionals. Be able to write functions. Know the difference between returning a value and printing a value. There's a pretty good chance I'll make a distinguishing thing on the exam with that, where I might say, write a function that does X, Y, and Z and returns and prints. And one of the things I'm going to be looking for is that you understand the difference between a function returning a value to whoever called it so they can use it for something else, versus a function that just displays something to the end user. Those are different things, even if the rest of the function is written identically. So that will probably make an appearance in probably multiple of the programming questions, because usually I'm going to say, write a function that does something and either shows you the answer or gives you the answer back to do something else with it. Understand the concept of the return statement, that the return statement makes a function end. It can then optionally return a value. So the return statement doesn't actually require you to spit a value out, but it does kill a method immediately, kill a function immediately. Usually, though, we would be returning a value with it, which says, kill the function and spit this value out. So certainly this number conversion stuff. So here's all your examples of converting between one numeric base and another. There won't be any questions regarding our specific tech talks. Again, that's something for foundational things that's going to carry you through your degree program, but not related to this course itself. This is a good example. If I asked you to write a function that calculates the area of a circle, I would tell you what the formula for an area of a circle is. for you to go and calculate it. You wouldn't have to pull that out of your brain somewhere. Be familiar with the collection types: strings, lists, and dictionaries. Strings are a immutable collection of chars. We can't change them directly. We have to build new strings with concatenation. Lists are mutable collections of anything. And dictionaries are name value pairs and are kind of the precursor to our classes that we've more recently introduced. Be able to use the length function for our collections. Definitely being able to work with strings, lists, and dictionaries is going to be a major part of several of the programming questions. You should be able to work with collections. Understand the break statement to get you out of a loop. It doesn't get you out of a function, it gets you out of the loop that you're in. If you said, I found what I'm looking for, I'm done doing whatever I was doing, so I need to get out prematurely instead of the loop running additional times. Similarly, the continue statement allows you to skip the rest of this iteration of the loop and just go to the next iteration if you just happen to know that I've finished checking for whatever I needed to check for here. Here's that variable passing thing again, pass by value versus pass by reference. Very, very, very important. Know that concept. And here's the description of that, how we're showing pointers where two things are pointing to the same place in memory versus two things pointing to two separate values. If I make changes, those changes don't impact each other. In versus not in, important concepts I probably won't. It might be one of those things that I'll ask you a question that you could use this for, but I probably wouldn't ask a question where I intend for you to use in or not in a collection. It might just be the way you think about solving that problem requires these, but yeah, so I won't ask you anything specific about in or not in, but you might need to use in if you use like the, for I in range 0 to 10 or something. It might just naturally be part of that. And this is that idea of side effect, which is the other side of pass by value versus pass by address. Here's our display of what scope looks like, how variables resolve to their most local definition. So if I have a variable called key inside of this loop here, it lives and dies with this loop. And then when this loop is over, our most local variables are what's defined in this red scope here, which is from a function called display inventory. And if I look for something in there and I don't find it, then it goes up to the more global scope where I have an LOL and a drag and loop variable. So this is just kind of giving a picture of, hey, we have a function and a function, and these guys' scopes live completely separate from each other. I can't access item count from this guy from within here. They're two separate scopes. But I can access drag and loop from both of these, because it is part of the global scope that both of these guys live within. So certainly understand how scope works. The concept that all programs begin and end with main is something you should have in your head, is something that's going to be much more prevalent, much more obvious in the next the next classes we get into, even though we forced it in the second part of the semester here in 200 by making us do a main method in Python and our main function in Python and calling it from that if name equals main thing. So we forced those separate scopes. Okay, and this kind of gets us to where we were for our, I won't ask anything about regular expressions. Important skill to know. It's a computer science-y type of ability, but it's not something that's like real commonly used in everyday programming. It's something that might apply well to like pattern matching type stuff. So I'm not going to test you over it because I don't think it tests core competency in programming. Okay, so I think that kind of covers everything for the exam. So questions about the exam, any concepts you want me to review or go over?
I have a question.
Sure.
Would you be able to go through like the differences between continue and break again, please?
Sure.
Thank you.
So let's just look at it through an example. So why don't we say for I in range 0 to 10 or 0 to 100, that's fine. Let's say that we're interested in the first value that is evenly divisible by, I don't know, 3 or something like that. So we're going to say print I, then we'll say if I mod 3 is equal to 0, then we will break. So, and then we will do a little print broke out of the loop. So this guy's going to go through. I is going to start off at 0. We'll print out 0. We'll ask, is 0 evenly divisible by 3? Nope. Spin back up. We'll print out 1. Is 1 evenly divisible by 3? Nope. Spin back up. Is 2 evenly divisible by 3? Nope. Spin back up. Is 3 evenly divisible by 3? Yes. So we'll break out. We'll print 3. We'll break out here because this will end up being true. So is 3 mod 3 equal to 0? It is. So we break, which will get us out of this function. All right, that makes sense? And then we'll say broke out of the loop. So when I run this, there's our, hold on. 0 mod 3 is, here, let's start it off at 1 because of how mod works. There we go. There's our 1, 2, and 3. 0 mod 3 actually does have a remainder of 0. This will go 1, 2, and 3, broke out of the loop. All right, so break gets us out. Even though it was inside of this if statement, it actually exited us, ejected us from this for loop. We didn't get to 4, 5, 6, 7, 8, 9 in this for loop because break got us out of there. Okay? So now what we might do here is I'm going to change this print, and we'll go ahead and say else print I. Let's see, let's do it this way. I'm going to print div3 if I'm in there. Then I'll continue. And I won't do this in an else. I'll say this guy always happens. Okay, so I'm going to go through 1 to 100, and actually let's go through 1 to 10, so it's a little shorter. And then I'm going to ask a question. If the current value I'm looking at is evenly divisible by 3, instead of printing out the value, we're just going to print out div3. And then we're going to continue. Continue says, don't continue to execute the rest of this stuff. So we will not get to this line of code. Instead, go to the next iteration of this loop. So when I have a 3 here, I'm not going to actually print 3. All we're going to see is div3. But when I have a 4, I'll print 4. I have a 5, I'll print 5. When I have a 6, I'll print div3, and then I'll continue. So I won't print a 6. I'll print a 7, I print an 8, I won't print a 9, so on and so forth. So there's our 1, 2, don't print the 3. 4, 5, don't print the 6. 6, 7, 8, don't print the 9. See how that's working? So it's allowing me to skip over this line because this print is not part of this if statement. It is part of the loop. So this print would normally happen every single time through this loop. But because I conditionally said continue on to the next iteration of the loop, it will skip to the very end of this loop, skipping over all the rest of the code in it and go on to the next thing. That make sense?
Yes, thank you very much. That was helpful.
I think in general, if I'm just kind of giving you like a rule of thumb, continue is not a super common thing you run into. It's probably more of an older school trick. I think more commonly now, somebody might just say, I'm gonna, just throw everything in an if else. That way only the stuff that happens in the if happens in the if, otherwise it happens in the else. I don't have to worry about kind of playing the hopscotch game of skipping over certain stuff, but it's still a thing. Break is going to be much more common. All right, other questions?
Can you briefly go over the syntax for reading, writing, and appending?
Sure. All right, let me, here I have a file already. So we'll go ahead and say, we'll have our file descriptor. It'll be open and input file.txt. Now by default, it opens for reading. You don't actually have to put that in there if you don't want. I'm going to put it in there so we see the differences here. So I'll open that file. Then I'll say s is equal to fd.read. That'll read the contents of that file in as a string. And then I can go ahead and print out the contents. So there's the contents of that file as a string. If I want to then get a list of the parts, I can say s.split. In this case, in my file, I just press enter at the end of each of these lines. So there's carriage returns in there. So now I can split it and then I can print out list of parts, and this will give me a list containing the individual lines in my file. Okay, so that is reading in from a file. Now, if we also want to be able to write to this file, I can open the file just for writing. If I want, I can also open it for reading and writing if I want both of those. But now let's just go ahead and open it up for writing. And just so I don't lose my content here, I'm just going to copy that for a second. So I'll go ahead. I don't even need to read in from the file now. So I'll go ahead and I'll say fd.write LOL \n, something like that. Now, if I just do that and I hit play, it actually will not change that file. So it ran. I did write to the file, but I wrote to it in memory. I didn't close the file, therefore it did not change the contents of this guy. Oh, it did. I thought we had proved last time that it didn't. So I thought I gave you warning that most programming languages require you to close. Most older programming languages require you to close the file after you make a change to it. This is appropriately written. If you open a file and you write to it, you should close it because that's the go-to move that actually takes it from memory and writes it out. And I had originally predicted that Python would do this for you, which I just showed that it did, but I thought in class we saw that it didn't. So maybe I didn't right-click on this or something. But good programming practice says if you open a file for writing, always close it. But important thing for us here, notice that when I opened it for writing, it overwrote the entire file. You know, I don't have my old stuff there anymore. So I'm going to go ahead and I'll paste the old stuff back in. Now I'll open that file for appending. Appending will add it to the end of that file. So now instead of overwriting the whole file, I just add it on to the end of the file. Does that make sense? And we can open it up for read and append. And I can go ahead and say print fd.read. That'll give me the contents. Then I'll write out a woot to the end of it and then close it. So I thought you can use more than one. It says you must have exactly one of those. Oh, I thought you could cheat it and write more than one. I guess not. I'm almost positive there's a way to do it. I must just be using the wrong syntax. But for now, just if you want to open it for reading, open it for reading. If you want to open it for writing, open it for writing. But I don't know, that was kind of weird. Because then I would have to open it a second time. FD2 is equal to open. So I could open a file a second time for appending. And then I can read it in, but when I write it out, I'll write to FD2 and then close FD2. So there's my reading it in stuff. But then when we go over here, we should have an extra woot written out to the end of it. That make sense?
Yep, thank you.
Okay. Now, hopefully you're seeing, as we're going through this, how quickly we can sit there and manipulate these things. I know that most of you can't do it this quickly, but hopefully this is the proof of concept that after you put in these reps, just like any video game, that when you first start playing, I've been playing Rocket League lately, and when I first started, I was terrible. And now I'm having fun with it because I don't suck horribly. But I feel like I'm kind of like CSC200 level student at Rocket League right now. So it's fun to play, but I missed the ball quite a bit. So it's the same kind of thing. As you keep building up your reps, things will become more natural. You'll just be able to write the stuff real quick without much thought. All right, well, I mean, class is over, so if you need to take off, that's fine, but I'm happy to stick around and answer any additional questions, and I'll keep the recording going if you want to come and review it. So anything else you want me to cover? Oh, they're dropping like flies.
So is it possible to do more with this? Like one of the examples you said was to read in some data and then count the number of times and was in it. So I'm assuming we would just add a loop to that somehow. Could we see an example of that?
Sure. Let's say this, for this example, since I have a bunch of them, let's say I'm looking for commas in there, because I have a bunch of commas in here. So let's say I'm looking for commas. So what we'll do is we'll just read it in. So we'll say S is equal to FD.read. So that'll read it in. And then, here we'll put it in a function format. So we'll say def count commas, and this guy will take a string as a parameter, and his job is to return the number of commas that are in this string. So we'll start off with a count of 0. We'll say for C in S, so C will be each character inside of my string S. If C is equal to a comma, count plus equals 1. In the end, I'll return count. Down here, I'll say num commas is equal to count commas, passing it S, and then I'll print num commas. Num commas. So there were 6 commas in there. 1, 2, 3, 4, 5, 6. That looks right.
Thanks.
Now, keep in mind, though, if you were trying to do it like for the a character sequence, like ands or 2 O's next to each other, something like that, you'd have to get a little bit more crafty with it, because now you have to walk through. You can't just look for individual chars. Individual chars are easy. But if you're looking for, let's say we have A and B, or C and D, something like that. So now we'll count the number of ands, but I happen to separate everything by spaces. So now what I'll do is we'll say def count ands. This guy will take in, well, we'll take in our same string here, but the very first thing we'll say is list of parts is equal to s dot split on a space. Actually, I think that's the default, is split like that. So now I can say for P in list of parts, if P is equal to and, we'll say count plus equals 1, and I need to give myself a count up here. Then I'll return count. So now in here, I'll say num ands is equal to count ands. And then I'll print out num ands. So I had 2 ands in there, 1 and 2. But the way I did that is I read in the string, I passed that string to count ands, but count ands took that string and split it on spaces. So it went through and gave me A, and then an and then a B, and then an or, and then a C, and then an and then a D. So it broke this up based on spaces. And then I went through all of those parts and counted any one that was equal to the string and. Does that make sense?
Yes, thank you.
All right, so I had to do one more level of processing in order to find strings in there. And that also benefited from the idea of these guys having spaces between them. If I didn't, I just had it all strewn together like this, then I'd have to go through and look for character sequences in a row that are equal to and, so that makes it even more complex. All right, other questions?
I noticed in line 3 of the programming right now, you used a semicolon at the end. Is that legal in Python?
Apparently it must be. Yeah, it must just ignore it. But it's not correct Python syntax. It must just ignore it as a symbol that it doesn't know what to do with. But most languages moving forward are going to have semicolons at the ends of the lines. But it would be improper Python to put a semicolon at the end of the line, even though it let me get away with it. Which is actually not very programming-like. Most languages are not forgiving when it comes to syntax, so I've just lost a little respect for Python, probably. All right, anything else? Going once, going twice. All right, well, I'm around all summer, so if you have questions or want to go over anything, that's I'm happy to meet up. Otherwise, I hope to see all of you in 250 next semester.
One more thing.
Oh, sure, go ahead.
So this is a bit of a side note, but what would be the next color belt if we wanted to get the...
Oh, well, you will get that. The next color belt is the yellow belt. So in 250, we hand out yellow belts.
Oh, okay. All right.
And then in 300, you get orange belts. And then when you graduate 300, that's when you start differentiating yourself, where you might have one person who has a green belt. So coming out of 300, you get a green belt. But then somebody else might be a blue belt. That means they're better than the green belt, right? They would win in a programming sparring match.
Yep.
In the department right now, we have some purple belts. We have several red belts. And we have a grad student. We have an undergrad and a grad student who are brown belts. So they're one below black.
Oh,
yeah,
oh
so
wow.
Blade is a brown belt, and Jack Michelet's is a brown belt. So as you go through the program, those are people that you know Blade, right?
I think so, yeah.
Chinese guy, my grad assistant.
Oh yeah.
He works on yeah, he's been a professional developer for years. He's only in school for immigration issues. So he's doing another master's.
Yeah.
Okay.
Yeah, I don't know. I thought we were getting belts at the end or something like that.
And usually I would. Usually I would give belts out at the end. So, I mean, if you're really interested, I will mail one to you. And I'm not kidding. If you legitimately want a belt, shoot me an email with your mailing address. I will mail one to you because
I will definitely do that. I can pay for the shipping if you want.
No, it's going to cost nothing to mail it.
Okay.
But yeah, I mean, that's the intent. The intent was you hand out belts. But unfortunately we're not face to face, so it is what it is.
Yeah. I don't know. I felt like I wasn't putting much effort this semester in terms of my programming assignments. I don't know. I think I might start out strong, but just being at home, it's just I haven't been putting much effort. I feel like